Hi, in today's session, we are going to discuss something more about the decimal expansion of a rational number. That is, without actual division, we are going to find whether a given rational number is terminating or non-terminating. Second, if terminating, after how many digits it terminates. Third, to find the terminating decimal expansion of a given rational number. All these 3 points we are going to discuss, and also we are going to see few examples. See the 3 rational numbers. I have first rational number 3 by 40, second 33 by 48, third 37 by 25. We are going to see whether the given rational number has a terminating or non-terminating decimal expansion without actual division. For that, first make sure that the given rational numbers are in the standard form, that is in the simplified form. It means the denominator and numerator have no common factor other than 1. Look at this one, 3 by 40. 3 and 40 have no common factor other than 1, so this is in the simplest form. The second one, 33 by 48. 33 by 48 is not in the simplest form because both the numerator and denominator have a common factor 3. So after cancelling the common factor 3, we get 11 by 16. Third one, 37 by 25, that is in the standard form. So, before using these techniques, make sure that all the rational numbers given are in the standard form. Then, you prime factorize the denominator of each rational number. So, here I am going to write the denominator of the given rational numbers in the prime factors form. Look at the denominators of each of these rational number. 40 is 2 cube into 5. 48 is equal, 33 by 48 is equal to 11 by 16. It is equal to 11 by 2 raised to 4. 37 by 25 is equal to 37 by 5 square. In all these 3 rational numbers, we can see that the denominator has only the prime factors 2 or 5, or both 2 and 5. In this rational number, the denominator has both 2 and 5. Here only 2, here only 5. So the point is, if the denominator of a rational number has the prime factors only 2 or 5, or both 2 and 5, then it will have a terminating decimal expansion. I repeat, if the prime factorization of the denominator of a rational number has only prime factors 2 or 5, then it will have a terminating decimal expansion. So these 3 rational numbers will have a definitely terminating decimal expansion. Then what about a non-terminating decimal expansion? Very simple. If the denominator of the rational number has any prime factor other than 2 or 5, then it will have a non-terminating decimal expansion. Make sure that all the rational numbers are in the simplest form. So, these 3 rational numbers have a terminating decimal expansion. Second point, if terminating, after how many digits it terminates. To find this, we will express the denominator of each of these rational numbers as a power of 10. To convert the denominator as a power of 10, we have to make sure that the power of both the 2 and 5 are same in the denominator. For example, here the power of 2 is 3 and the power of 5 is 1. We have to make the power of 5 also equal to 3. For that, we have to multiply here with the 5 square. We cannot multiply only the denominator. At the same time, we will multiply the numerator also by the same number. So, we get 3 into 5 square divided by 2 cube into 5 into 5 square. Now I am going to simplify the numerator. It is equal to 3 into 25 by 2 cube into 5 cube. 2 cube into 5 cube is 2 into 5 the whole cube. It is equal to 75 by 10 cube. After reaching this step, now I can say that this decimal expansion, that is the decimal expansion of 3 by 40 will terminate after 3 digits. The power of 10 decides after how many digits the decimal expansion terminates. So here the decimal expansion of 3 by 40 will terminate after 3 digits. Third point, to find the decimal expansion without actual division. Now you have 75 by 10 cube. This 3 means there will be 3 digits after the decimal point. So you write 75 with the decimal point such that there are 3 digits after decimal expansion. See what will be the decimal expansion. Here the decimal expansion of 75 by 10 cube, 10 cube means 1000, is equal to 0.075. Now let us take this next example. It is 11 by 2 raised to 4. Here the denominator has no 5. We have to give 5 in the denominator also. The power of the 5 also should be same as that of 2. So we have to multiply both the numerator and the denominator by 5 raised to 4. Here on multiplying the numerator and denominator by 5 raised to 4, we get 11 into 5 raised to 4 is 625. Denominator is 2 into 5 the whole raised to 4. 11 into 625 we get 6875 divided by 2 into 5 10 raised to 4. Here the denominator is expressed as a power of 10 and the power of 10 is 4. That means the decimal expansion of 33 by 48 will terminate after 4 digits. And the decimal expansion of 33 by 48, that is 11 by 16, can be easily written as 0.6875. Why? Because the decimal expansion of 11 by 16 should have 4 digits after the decimal point. So I put the decimal point in such a way that there are 4 digits after the decimal point. Now we are coming to this one. 37 by 25. It is in the simplest form. On prime factorizing the denominator we have 5 square. To find after how many digits the decimal expansion terminates, we have to write the denominator as a power of 10. So by which number we have to multiply here? By 2 square. After expressing the denominator as a power of 10, we get 148 by 10 square. That means the decimal expansion of this number will terminate after 2 digits. That means there will be 2 digits after the decimal expansion. And how to write the decimal expansion? It is simple. It is equal to 1.48 because the power of 10 is 2. So 2 digits after the decimal point. So I put the decimal point such that there are 2 digits after the decimal point. So this is how we can find out whether a given rational number has terminating or non-terminating decimal expansion. So here, first make sure that given rational number is in the standard form. That is, there is no common factor between the numerator and the denominator. Then prime factorize the denominator and see if the denominator has any prime factor other than 2 or 5, then it will have a non-terminating decimal expansion. If the denominator has only prime factors 2 or 5, then it will have a terminating decimal expansion. Now look at another question. 257 by 5000. First we will see whether this rational number has a terminating or non-terminating decimal expansion. Second, if terminating, after how many digits it will terminate. And third, what is its decimal expansion. For that, first of all, we have to prime factorize the denominator and see whether the denominator has any prime factor other than 2 or 5. On prime factorizing, we get 5000 is equal to 2 cube into 5 raised to 4. The prime factors are only 2 and 5, so it has a terminating decimal expansion. Now to find after how many digits it will terminate. For that, we have to write the denominator as a power of 10. For that, the powers of both 2 and 5 should be same. Here the power of 2 is 3 and the power of 5 is 4. We have to make the power of 2 also equal to 4. For that, we will multiply both the numerator and denominator by 2. And as a result, we get 514 divided by 2 raised to 4 into 5 raised to 4. It is equal to 514 by 2 into 5 the whole raised to 4. It is equal to 514 by 10 raised to 4. The power of 10 is 4, therefore the decimal expansion will terminate after 4 digits, and hence we can write the answer, that is the decimal expansion of this rational number is equal to 0.0514. Here I hope you understood why I put a 0 here, because the power of 10 is 4. Therefore, there must be 4 digits after the decimal point, but we have only 3 digits, so I put a 0 for that. So the answer is 0.0514. So in this way, you can find whether a given rational number has a terminating or non-terminating decimal expansion. If terminating, how many digits there will be, and also what is the decimal expansion.